Good day, everyone. You are welcome back to Idowu Math class. Today we want to consider another very important topic that you are going to face in your UTME mathematics, and the topic is calculus. Calculus is divided into two. We have differential calculus, we have integral calculus. Today we are starting from differential calculus. When we say differential calculus, what do we mean? Given the function y equals x raised to power n, let's say this is our y function, the y dx, which means the change in y with respect to x is nx raised to power n minus 1. Look at what I have written here. This is just a demo that will show you what we do in all cases when you are given a function, especially when the function contains sum and difference only. So the y dx, which is the derivative of the function y with respect to x, is given as this. What do we mean? Let's consider this example, example 1. Find the dy dx, that is, the change in y with respect to x, if y is equal to 3x raised to power 4 minus 2x raised to power 3 plus 4x plus 3. The y dx here, which is the derivative of this function y with respect to x, means just follow the pattern up here. Look at this. At first, the power of the variable x here is 4. Use it to multiply this 3. It will give us 12x. Now write the power raised to power 4 minus 1. For doing that, you subtract 1 from the power. Do the same thing to this, and that is minus. This power 3, use it to multiply negative 2. It gives us negative 6x raised to power 3 minus 1. Do you understand? That's the excess of the negative 1 you see here, n minus 1. Then plus 4. This is 4x raised to power 1 minus 1. We believe that the power of x here is 1. When you use the 1 to multiply 4, it's still 4. 4x raised to power the 1. You now let the power be feasible. It has been feasible before. Let it be feasible now. You now subtract 1 from it. Plus 0. The derivative of a constant is 0. That is, the differentiation of a constant is 0. Whether negative constant or positive constant, the differentiation is 0. Do you understand? Now, the result here will be 12x raised to power 3, because 4 minus 1 is 3, minus 6x raised to power 2. 3 minus 1 is 2, plus 4. The reason it's going to be 4 is this. Let me show you. It's going to be x raised to power 0, because 1 minus 1 is 0, plus 0. And don't forget that in indices we say anything that is raised to power 0 is 1. You can see that this variable x alone carries the power 0, and that makes it to become 1. So x raised to power 0 is 1. 1 times 4 is 4. That's why it is 4. Plus 0 is just like that. And this is the result. This is the derivative of this, and that is the dy dx. Do you understand? Now, let's go into UTME past questions. Let's consider example 2. Find the derivative of y equals 2x raised to power 3 minus 2x raised to power 2 minus 1. The derivative is the y dx, that is the change in y with respect to x, which is going to be 3 times 2, that is 6, x raised to power 2, that is raised to power 3 minus 1, minus 4x raised to power 1. And x raised to power 1 is written as x, not necessarily putting the 1 there. Then the derivative of negative 1 is 0, so this is the answer. And that tallies with option C is the correct answer. Let's consider example 3. Given that y equals x over 2 minus x squared, find the y dx. Let's first rewrite our function as half x minus x squared. You know, it's the same thing. And don't forget that the derivative of a variable with power 1 is its coefficient. The coefficient of this x, the x here is having power 1. The derivative of something like this is its coefficient. And the coefficient of x here is half. Therefore, the y dx of this is half. While the derivative of negative x raised to power 2 will be negative 2x raised to power 1. No, 2x raised to power 1 is the same thing as 2x. So, this is the answer. Let's scan through the options. You can see it's like there is no answer in the option, but it is there. That's jam for you. You are expected to manipulate it to be in their own format. And what is done there, we factorize. What is the HCF to these two terms? What is common to the two terms? Half is common. Bring the half out. The half you bring out. Use that half to divide the first half here. It gives you 1. Use the half to divide negative 2x. It gives us negative 4x. And that is it. If you use it to divide it, let's see. Negative 2x divided by half. It means negative 2x times 2, which is negative 4x. And that is why we have it like that. So this is the answer. And that tallies with option B. Option B is the correct answer. Let's look at example 4. Find the y dx if y equals x minus 4 over x. Let's rewrite our function as x minus 4 into 1 over x. Remember, minus 4 into 1 over x is the same thing as minus 4 over x. If you use minus 4 to open this bracket, remember, the minus 4 will multiply the 1. It will give us minus 4 over x. So, this is still rewritten as minus 4x raised to power negative 1. Remember, I expressed 1 over x in index form. So, we have minus 4x raised to power minus 1. Therefore, the y dx equals, the derivative of x will be 1 because the coefficient of x is 1 and x is having power 1. The derivative of a variable with power 1 is the coefficient of that variable. So that is it. That is why it is 1. Now, the derivative of minus 4x raised to power minus 1 is positive 4x raised to power minus 2. What have I done? Look at it. Use the negative 1, that is the power. Use it to multiply negative 4. It gives us positive 4. That positive 4x raised to power minus 1 minus 1. You subtract minus 1 from the minus 1. So, and that gives us minus 2. When you have minus 1, you have minus 2. So, that is the answer. And that tallies with option C. Option C is the correct answer. Let's consider example 5. Given that the derivative of y equals 3x raised to power 3 minus 4x raised to power p is 9x raised to power 2 minus 12x raised to power 2. Find p. The question is the y dx of y equals 3x raised to power 3 minus 4x raised to power p is 9x squared minus 12x squared. And that derivative is also, by your own manipulation, if you do your own directly, it's also equal to 9x raised to the power 2 minus 4px raised to power p minus 1. So if this is equal to this, we can affirm that truly this is equal to this term, this first term is equal to the first term here. Therefore, also minus 4p x raised to power p minus 1 is also equal to minus 12x raised to power 2. Now, we have to do comparison, whether power comparison or coefficient comparison. Whichever we do, we have to get the answer. If we want to do power comparison, the power here is p minus 1, which must be equal to the power here, which is 2. The power here is 2. So if you equate them, then you have p equals 2 plus 1, p equals 3. The correct answer is option D. If you want to do the coefficient comparison, you say that minus 4p, the coefficient of x raised to power whatever here, is minus 4p, which must be equal to the coefficient of x squared here. The coefficient of x squared here is minus 12. So dividing both sides by negative 4, you have p equals minus 12 divided by minus 4, p equals 3. You can see you are going to get the same answer. So the correct option is option D.